cross section area is given as 200 mm by 300 mm. So area of concrete will be equal to 6 into 10 power 4 mm square. Given Young's modulus of concrete as 5700 root FCU, where FCU is given as 42, so 5700 into under root of 42, which will be equal to 36,900 Newton per mm square. I will be equal to BD cube by 12, that is 200 into 300 cube by 12, which will be equal to 45 into 10 power 7 mm to the power of 4. Alpha modular ratio will be equal to ES by EC, that is equal to 210 in kilonewton per mm, so into 10 power 3 to convert into Newton per mm square, by Young's modulus of concrete is 36,900, so that will be equal to 5.7. Pre-stressing force will be equal to stress into area, that is 10 wires of each area is pi by 4 into 7 square, that is equal to 462 kilonewton. So the stress in concrete at the level of steel Fc will be equal to P by A plus PE by I into Y. Given that the tendons are located 100 mm from the soffit, then eccentricity will be equal to, since overall depth is 300, 150 minus 100, which is equal to 50 mm. So the stress in concrete at the level of steel will be equal to P is 462 into 10 power 3 to convert into Newton, by cross section area is 6 into 10 power 4 plus P is 462 into 10 power 3 in Newton into eccentricity is 50 mm, by I is 45 into 10 power 7 into Y is also 50 mm, distance from neutral axis to the location of the wires, that is same as E. So this will be equal to 10.3 Newton per mm square. This is loss of stress. Then knowing Fc, loss of stress due to elastic deformation of concrete will be equal to alpha into Fc, that is equal to alpha is 5.7 into Fc is 10.3, which is equal to 58.8 Newton per mm square. Knowing the loss, then force in wires immediately after transfer will be equal to loss in stress is 58.8, initial is 1200 minus 58.8 into area is 10 wires of each area pi by 4 into 7 square, so that will be equal to 439.362, nearly 440 kilonewtons. Now stress in concrete at the level of steel now will be equal to Fc, that is equal to now P by A plus PE by I into Y. Now P is 440, so 440 into 10 power 3 in newtons, by cross section area is 6 into 10 power 4 plus P is 440 into 10 power 3 into eccentricity is 50 into Y is also 50, by I is 45 into 10 power 7, so that will be equal to 9.78 Newton per mm square. So the type of losses in the first losses due to elastic deformation of concrete, it is obtained as 58.8 Newton per mm square. Second is due to creep of concrete. which is obtained using creep coefficient method, that is phi into Fc into alpha modular ratio, that is equal to phi is 1.6 into Fc is 9.78 into alpha is 5.7, which is equal to 89.2 Newton per mm square. Third loss is shrinkage of concrete, which is equal to residual shrinkage strain epsilon Cs into Young's modulus of steel, which is equal to, this is given as 3 into 10 power minus 4 into Young's modulus of steel is 210 kilonewton per mm square. So into 10 power 3 to convert into Newton per mm square. So this will be equal to 63 Newton per mm square. Fourth loss is relaxation of steel. Relaxation of stress in steel, which can be taken as 5% of the initial stress. 5% of initial stress is 1200, that is equal to 5 by 100 into 1200, which will be equal to 60 Newton per mm square. So the total loss will be equal to 271 Newton per mm square. And the final stress in wires will be equal to initial minus loss. Initial is 1200 minus loss is 271. So that will be equal to 929 Newton per mm square. And the percentage loss will be total loss by initial 1200 into 100 to convert into percentage. So that will be equal to 22.58%.